Hello everyone, today we'll talk about the solution to the problem construct K Palindrome Strings. This problem, as you can see, has a very short statement and also a very short solution because it introduces us to a single trick, a single idea. Now, we know that a palindrome, of course, is a word that is the same when read forwards and read backwards, and another way of looking at it is that it has a middle, and that middle is either between two characters if the palindrome is of even length, or it's a single character in the middle if the palindrome has an odd length. And now the middle we don't care about, it can be anything. So for an odd length palindrome it can be any letter we want. And then to the left and to the right of the middle, at every position we have to have the same letter. So right next to the middle, the letters have to be equal. One jump from the middle, letters have to be equal, and so on. And that perspective is useful when solving problems like this. For instance, how can we use the letters from our string S to construct some palindromes? Well, one thing that we might come up with is that if some letter appears an odd number of times in our string S, then it cannot be a member of any palindrome of even length. Well, it can be, of course, of any of even length, but at least one instance of it cannot be paired up with another instance, right? If we have an odd number of occurrences and we try to pair them up, then one would always remain unpaired. And that one that remains unpaired has to be a start of any palindrome, of some palindrome that we want, right? So that means that for every letter that occurs an odd number of times, it has to be in a separate palindrome because it has to be the middle of that palindrome, that one leftover instance of that letter. And that's actually all that we need to check in order to make sure that we can create those K palindrome strings. So we can count the number of letters that occur an odd number of times. So we just create a counter of values of letters that we have, so how many times every letter appears. That's the counts. And now for every v in counts values, so we don't care about which letter it is, only how many times it appears. If it appears an odd number of times, then it's an odd occurrence. And now the number of odd occurrences cannot exceed k, because if we have more odd occurrences than we have K palindromes that we want to create, then we will have to create more palindromes than needed. I also have added here a check, of course, to check if K is less than or equal to S, because if K is greater than the number of letters, we cannot create those palindromes. Or maybe if we could create empty palindromes, then the answer would be, in this case, true and not false. But that's just an edge case. We have to, I guess, clarify what the requirements are. So, again, just the number of odd occurrences is enough. It certainly gives us a lower bound, and that lower bound is exactly what we care about in this problem. And to see if we wanted, for instance, to create actually those K palindrome strings, what we can do with... So first we take every letter that occurs an odd number of times, and we put one occurrence of that letter as a start, as a middle of some palindrome. And now we have some set of letters that occur an even number of times. And now we can do whatever we want with them. If we take two occurrences of a letter and put it to a palindrome, one on the left, one on the right, then we don't care about which palindrome we put it into, we just eat those two letters and that's it. And if we need more palindromes, we can simply take a letter and create a palindrome, a single palindrome consisting of only that letter or only two of that letter. So the letters that occur an even number of times give us a lot of options, and it's only those that occur an odd number of times that limit us. So this is the whole solution to this problem.